Solar power plants can fail or experience significant issues due to a range of factors, spanning technical, environmental, operational, and external influences. Here is a detailed analysis of common causes of solar plant failures. Over time, solar panels experience gradual degradation due to exposure to sunlight and weather conditions. This is a natural process but can be accelerated by environmental factors like intense heat or rapid temperature changes. Potential induced degradation (PID). This occurs when voltage differences between the solar cells and the frame of the module cause a loss in power output. PID is often a result of improper grounding or insulation issues. Microcracks in solar cells. Microcracks can form in the silicon cells due to thermal expansion, physical impact, or manufacturing defects. These tiny cracks can reduce the efficiency of the solar panel over time by disrupting the electrical pathways. 2. Inverter failures. Inverter faults. Inverters, which convert DC power generated by solar panels into AC power for the grid, are one of the most common sources of failure in solar plants. Issues like overheating, poor ventilation, and component wear can lead to inverter breakdowns. Grid connection issues. Poor synchronization with the grid can cause inverters to shut down to prevent damage. Fluctuations in grid voltage or frequency can also trip the inverters, leading to downtime. Inverter software issues. Modern inverters use complex software for maximum power point tracking (MPPT) and grid management. Software bugs, misconfigurations, or firmware issues can cause unexpected shutdowns or suboptimal performance. 3. Wiring and connection issues. Loose or damaged wiring. Over time, the connections between panels, inverters, and the grid can become loose or corroded, especially in harsh weather conditions. This can result in power losses, system failures, or even electrical fires. Rodent damage. Rodents can chew through cables, leading to short circuits or reduced power output. Using protective conduit or rodent-resistant cabling is essential in areas where this is a risk. Connector failures. DC connectors, which connect solar modules in a string, can fail due to poor quality materials, improper installation, or thermal expansion. This can result in partial or complete string failures. 4. Environmental factors. Extreme weather events. Hailstorms, strong winds, lightning strikes, and floods can physically damage solar panels or other components of a solar plant. In extreme cases, panels can crack, mounts can be damaged, or inverters can be flooded. Dust, dirt, and pollution. Dust and soiling can accumulate on the surface of solar panels, reducing the amount of sunlight reaching the solar cells. This can decrease energy production by as much as 20–25% if left uncleaned for extended periods. Snow accumulation. In colder climates, snow can cover the panels, blocking sunlight and halting production. While most panels are designed with a tilt that encourages snow to slide off, heavy accumulation can lead to structural stress. 5. Poor installation practices. Improper mounting and tilt angles. Incorrectly installed mounting systems or poorly aligned panels can reduce the efficiency of energy capture. Moreover, weak or inadequate mounting can result in panels becoming dislodged during storms. Shading issues. Installation errors, such as placing panels where they are partially shaded during peak sunlight hours, can significantly reduce power output. Even minor shading can impact the performance of a whole panel string. Inconsistent quality control. Using substandard components or cutting corners during installation can lead to early failures. High-quality installation practices are crucial for ensuring the longevity and reliability of a solar power plant. 6. Thermal management issues. Overheating of panels. Solar panels operate less efficiently when they become too hot. This is a particular concern in areas with high ambient temperatures and insufficient ventilation. If the panels are not adequately cooled, their efficiency and lifespan can decrease. Hot spots. If part of a solar panel gets shaded while the rest remains in sunlight, it can create a hot spot that significantly reduces the lifespan of the panel. This localized overheating can damage the cells and reduce overall output. 7. Monitoring and control failures. Monitoring system failures. Solar plants use monitoring systems to track power production and system performance. Failures in these systems can lead to undetected drops in performance, resulting in significant energy losses over time. Inadequate data analysis. Even with monitoring systems in place, if data is not analyzed properly or maintenance actions are not taken promptly, minor issues can escalate into major failures. Proactive data analysis can identify performance trends and anticipate failures. 8. Human error and maintenance lapses. Neglecting regular maintenance. Solar plants require periodic inspections to ensure all components are functioning correctly. Cleaning panels, checking for loose wiring, and inspecting inverters are part of regular maintenance that prevents failures. Improper repairs. Incorrectly executed repairs or the use of non-compatible replacement parts can worsen issues rather than resolve them, leading to further breakdowns. Operational mismanagement. Errors in adjusting power settings, disconnecting systems from the grid, or misconfiguring system parameters can cause operational failures. 9. Manufacturing defects and product failures. Defective panels or inverters. Manufacturing defects, such as poor lamination or substandard materials, can lead to early failures in solar panels and inverters. While most manufacturers provide warranties, defective products can disrupt the performance of a solar plant. Component wear out. Components like bypass diodes, connectors, and capacitors can wear out over time. In some cases, these components may fail sooner than expected due to substandard manufacturing. 10. External factors. Regulatory changes. Changes in local policies, tariffs, or grid connection regulations can affect the operation and profitability of a solar power plant, leading to partial or full shutdowns. Power Purchase Agreement (PPA) disruptions. If there are contractual or financial disputes with the utility or the off-taker of the electricity produced, it can impact the operation of a solar power plant. Summary. Key points to prevent solar plant failures. Conduct regular inspections and maintenance to identify and address potential issues early. Use high-quality materials and ensure proper installation to reduce risks associated with wear and tear. Implement robust monitoring systems to track performance and detect issues in real time. Ensure proper site selection to minimize risks from environmental factors like shading and extreme weather. Understanding these potential causes of failure helps in designing more resilient solar plants, ensuring they perform effectively throughout their intended lifespan.